Okay, so welcome back, and now we're going to do another rule, and this is about integrals of even and odd functions. So again, this is something you should remember from your days of college algebra or pre-calculus. Okay, so what do we know about even functions? Even functions are symmetric with respect to the y-axis. Okay, and odd functions are symmetric with respect to the origin. And so it gives you a visual of what they look like, and it'll make sense. What I'm going to read and what I'm going to go over with this rule will make perfect sense. Okay, so for a continuous function such that f of negative x is equal to x, again that's the definition of an even function. Okay, then this is true. If you take the integral from negative a to positive a of the function, it's the same as if you double it. Take the integral from 0 to a and then double it. Why? Because it's symmetric with respect to the y-axis. Okay? So if you're going from negative 2 to positive 2, then all you have to do is go from 0 to 2 and then double it and you get the same area. Why? Because it's an even function which is symmetric with respect to the y-axis. Okay? Now, for odd functions, right? So for continuous functions such that this is true, again, this is the definition of an odd function. Now what does that mean? It's symmetric with respect to the origin, right? So that means on one side you've got the mirror image, but it's the mirror image that's inverted and then it's flipped down or up depending on the graph, but it's reflected across the y-axis and then across the x-axis, so you get an inverted. Okay, so now if you take that type of function and you know it's symmetric with respect to the origin, guess what? If you go from negative a to positive a, that integral will equal 0 because you've got the exact same area underneath the x-axis as you do above the x-axis, and they cancel each other out, so you'll always get 0 if it's an odd function. Okay, and that's it.